Okay, to continue the discussion that we started on Thursday, helping you review, I was going to go ahead and pick up with the second half, the technical explanation. Look, got it right up here. This was talking about wired connections, okay, cable, digital, whatever. So I'm just going to go through the terms. First of all, fiber optic cable is a glass. It's a fiber that carries a light pulse. And that's how the signal is encoded. It's through bursts of light that shoot down a fiber optic cable. And you can carry a lot of bandwidth. They are wide open in terms of bandwidth. They also can travel long distances with little attenuation. It's a highly efficient way to send a signal. Next would be a fiber optic cable. Now, not fiber optic, a coaxial cable. Coaxial cable has a center core, and then that's surrounded by an insulator, dielectric, and then that has a shield around that. Most of the coaxial cable that you see would be like for a video cable or for like a cable connection to the wall, but they can really get big. They use coaxial cable. I mean, a transmitter coaxial cable, like the one that carries the signal for WNGR to the antenna. That's also a coaxial cable. The key to remember about coaxial cable, it has a center core, a dielectric insulator, a shield, and then uh, an outer protective jacket. These are also higher bandwidth than, let's say, an audio cable or something. And that's the key with cabling, bandwidth. How much data can be transmitted across that cable. Going next, twisted pair. Twisted pair is like an Ethernet cable, and it can carry a lot of data as well, computer data. It comes right now. You have Cat 5 and you have Cat 6. Just for your purposes, it's a high bandwidth digital cable that can be used to carry a variety of signals as long as it's been encoded to a digital signal. Head end. That's the main location, the central location for your cable operation, where they have administrative offices, sales offices, downlinks, the antennas to pick up local and distant television stations. That's the cable head end. It's where the business is, as well as the engineering. Hybrid fiber coaxial network. Okay, that is a system that for distributing cable. Also, primarily it's used though for digital, like internet connections. You have fiber to get out to major nodes within a neighborhood. We have this at my house, near my house, and then they use the existing copper infrastructure to get into the houses themselves. Instead of running fiber all the way into the house, they run fiber to a node and then they convert over to cable. Not quite as high a bandwidth as straight to the home with fiber, but still higher bandwidth. Pardon me, IPTV, Internet Protocol Television, IPTV. Just basically it's watching television type programming on your internet, video, in other words. Fiber to the home. Well, unlike the hybrid system with fiber and copper, fiber to the home is fiber running all the way to the home with maximum bandwidth. Cable as a closed system. Okay, cable is not a it's not a broadcast system. Pardon me. It's a system where the signals live on wire. Therefore, it's not a broadcast system. It should be a closed system. So a television nearby should not pick up the cable signal unless there's leakage. That would be called signal egress. Or you shouldn't have interference coming in. That would be signal ingress. Rather, cable is supposed to be a closed system. That's why it's not regulated as a broadcaster. And since I mentioned egress and ingress, you know what those are: addressable converters, more old school technology, but it's the cable box on your home and that actually has an address. If you're just getting standard cable channels, you probably just go directly into your TV set. But if you can be using pay-per-view and things like that, where they need to know what house is getting the signal, then they would install an addressable converter. Uh, this technology is probably going more and more out of the way as people move more and more to digital, where you have a modem and then they can you can buy products that way, video programming that way. But it was kind of the intermediate stage between what we have now with computers and the old days when you really didn't have an identity in the cable system. Uh, DVR, digital video recorder, built-in hard drive. Microwave distribution, just simply using microwaves to send signals around. We use this for EFP production. Whenever, like in a football game, we'll send a microwave signal, shoot it back to the station. Um, it's also, yeah, that's, any sort of location shoot. Microwave is a one way to get the video signal back. It's high bandwidth, very directional. You can point it to the station, and that's where it goes. They use the same type of technology for, say, phone systems, as well as for some digital internet transmission systems. Satellite distribution. Well, whereas microwave is, straight across, satellite distribution signal goes up, it's the bird, comes down, and it's downlink, received by a downlink. Satellite distribution sends out to a wide footprint on the surface of the Earth where the signal can be picked up with people who have an appropriate satellite reception dish. These can be the old-fashioned TVROs, which are the big 2 or 3 meter dishes, the old-fashioned big ones. Most people now, though, as consumers, use DBS, direct broadcast satellite systems, or direct broadcast satellite. And they're much smaller, maybe 24 inches, thereabouts, fit on your house. Very inexpensive as opposed to a few $1,000s to set up a TVRO or a big dish. Staying around the satellite distribution subject, C-band and KU band are different bands within the electromagnetic spectrum where satellites transmit their signals. And you have KU band satellites and you have C-band satellites. Geostationary orbit. Okay. And I'm going to be looking at myself in the monitor, which is why I'm looking away from you on the camera. So you have the surface of the Earth, and a satellite's in the sky. And as the Earth turns, the satellite also stays in orbit over that same point of the Earth. So it's stationary relative to a position on Earth, geostationary orbit. Uplinking and downlink. Uplink is when an uplink is when you send a signal up to the bird, and then downlink is the receiving dish on the Earth. Now, technically, you have an uplink, which is a receiver on the satellite, and then the downlink, which is the transmitter down. But we refer to them often just in general usages. The downlink is what receives, the uplink is what transmits to the satellite for the downlink to receive from the satellite. What else? Okay, transponders. These are the individual receivers on a satellite and transmitters on a satellite in orbit. The satellite receives all the signal, and the transponder sends down specific like channels, but just tuned. They're not really called channels. You'll have transponder number 1, number 2, number 3, number 4, and those are actually discrete pieces of equipment that take the satellite signal and then transmit it back to Earth for a specific discrete satellite signal. What else? Satellite footprint. We've mentioned that's the area on the Earth where that satellite signal can be picked up. HTTP, hypertext protocol, and Hotmail hypertext. These are just two formats for encoding for the universal coding so that computers can talk to each other on the internet. ISP is your internet service provider. VoIP, VoIP, voice over internet protocol. Telephones, using voice technology over the internet as opposed to a standard telephone. What else? URL, Universal Resource Locator. That's that's the identity on the internet for where you would go to get stuff. Cyber squatters, people who get a domain name and they just live on them and kind of hold them in ransom so somebody will buy them from them. Digital subscriber line, DSL, is what they're talking about there. It is just a higher bandwidth in your standard telephone modem. Higher bandwidth signal for at-home internet usage. cable modem. That's the device that your cable plugs into to make it a internet connection point, because since it's digital down your cable line. Wi-Fi is you go into your modem and then you go to a wireless transmitter so you can use Wi-Fi on your computer. Now, WiMAX is kind of like Wi-Fi on steroids. You have a much broader area for broadcast, much larger area. Don't worry about GSM. Mobile DTV is, watching TV on this. Let's see. So that's the end of the discussion for technology, that coupled with what we discussed in class the other day. Another discussion will be forthcoming.